Alright guys, welcome to this page of the notes. The last thing I want to do is take a look at you real quick about inscribing a quadrilateral, in this case a square. There are a lot of designs that are based on drawing squares inside of circles, especially when it comes to like tile work, brickwork, things like that, a lot of times in landscaping. And so all we want to do is just talk about how would you go about actually creating that square inscribed inside of a circle. Hopefully you should remember this theorem from the previous section. We talked about the inscribed angle of a diameter theorem in the previous set of notes, and it's going to be really important here when it comes to actually talking about how will we go ahead and inscribe a square inside of a circle. Here we go. Let's run through this. It should be a fairly simple, straightforward process. I think you'll get it. The first thing that you're going to need to do, right, is draw a diameter. Use a straight edge. You're going to use a straight edge to draw a diameter. If you did so, it would look something like this. I would have a circle. I would have the center of the circle. You just need to make sure, right, that your line goes through the center of the circle. And as long as you're drawing it with a straight edge, you know that that would then be a diameter. So now that you've got your diameter, step number 2, again, since you've got that straight edge, a ruler or something like that, what you're going to do then is draw 2 chords, right? You need to draw 2 chords connected to the end points of your diameter that go to and create an inscribed angle. As long as those chords are the exact same length, you'll know that it'll create a 90-degree angle. So construct or draw, same thing, 2 chords of the same length, creating an inscribed angle. If you did so, again, the idea here is that they would have to be 2 chords of the exact same length. So I've got my circle, I've got my diameter drawn inside my circle. I draw my 2 chords. Those 2 chords would have the exact same length and they would create an inscribed circle. So it would look something like that. Now here's what I know, right? Because this is a diameter and those chords have endpoints on the diameter, thanks to the theorem above, that inscribed angle of a diameter theorem, I know that this guy is a 90-degree angle. And remember, a square, all of the angles are 90 degrees. In addition to the angles being 90 degrees, the lengths of the sides are all the same, which is why it's important that those chords both be the exact same length. That way all the lengths will be the same. Then finally, step number 3, you're just going to take that image that you drew, reflect it to the other side of the circle, reflect the inscribed angle, across the diameter, right? Remember, reflect means you're going to take that inscribed angle, you're going to reflect it across the diameter, you'll get a mirror image on the opposite side. Since the length of these 2 chords are the same, my reflected image will have 2 chords that are the exact same length, and if this is 90 degrees, it'll be 90 degrees as well. So by reflecting it, what we wind up with then, right here, draw my last picture. I had my circle. Oh geez, that circle got ugly. I can do better. Yes, we're freehanding. It's not going to be perfect, but geez. Okay, circle. There's my diameter. Keep in mind, I just drew an inscribed angle that I knew was 90 degrees. I'm now going to reflect that guy across that diameter, so we give that guy a little spinny spin, 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 and what I wind up with is a mirror image over here on this side. which also must be 90 degrees. All of those have to have the exact same measure. All those chords will be the exact same length, and I wind up with a square inside of my circle. We have constructed a square, right? So that's going to be the easiest way to go ahead and draw an inscribed square inside of a circle using that inscribed angle of a diameter theorem. All right, guys, I had a great time taking a look at this stuff, dealing with inscribed quadrilaterals as well as inscribed squares with you. Remember, as is always the case, we're using a little bit of geometry to then wind up doing essentially what is an algebra problem. This chapter is no different. I had a lot of fun looking at it with you. I'll see you guys next time.